they're the exits. Today, at the moment, our energy demand has risen by more than 25% in the last 10 years. At the moment, our energy is coming from nuclear power stations and fossil fuels, which, as we know, are a finite resource, and they also produce carbon monoxide and carbon dioxide, which is harmful to the environment, as we all know. Because of this, it makes sense to find other sources of energy which are renewable. And at the moment, the renewable sector is actually a huge industry in engineering. There are huge developments being done in the Bend and Firth to harness the power of their wave and tide. We start off with one of the earliest forms of wave energy is the duck. But it's not that sorry. The Salter Duck Wave Energy Converter. Try and say that 3 times fast. It's developed by a man called Stephen Salter in Edinburgh. It comprises of tear-shaped sections on a single rotating axle. When the wave hits the curved edge, it will bob up and down, hence it's called the duck. This, bobbing up and down, rotates the axle, which turns the generator. There's the man himself. In the tank, the testing tank, the efficiency of the duck was about 80%. But when the prototype went out to open water, it dropped to about 50%. But still not too bad. And that's the basic principle of it. The axle will be on this section here, rotating it, and I'll show you the video, if I can.
Pressing it again.
Pardon?
Have you got a video stored on my pen drive?
No.
Past it.
Go past it. Okay.
You're logged on as yourself.
Yes.
Escape it and just click on it if you video.
As in on the internet?
Yeah.
Let's see if I have got it. So awkward.
The worst good of I love you.
Oh, I know what's on. One more. Alright.
Click on no.
The video I'm about to show you is from a company called Webtos. And their design is in the shape of a V, whereas the Salter's design is just basically a straight line, but works on the same principle. The waves, as you can see, are so random, and the duck compensates from this all the way along the length. There is the axe as a ratchet mechanism. As you can see, rotates one, but it doesn't rotate the other as it falls. Because that's just one duck that you're seeing, it does stop, but can you imagine the line of them rotating in the same way, so you do get a full rotation. The Webtos design here changes its angle to to compensate for the roughness of the waves to make it more efficient. Back to the presentation. The fall of the duck. The duck, the government survey said that the duck would be 10 times more expensive per unit of electricity to produce than the power systems of the time. But unfortunately this was a miscalculation. It did make the project shut down 19th of March 1982. The snake. A man called Richard Yem developed the duck to produce the snake wave energy converter. There's a picture of it. The snake is made up of long tubular sections with small power sections in between. These power sections have contain pistons which force material, usually oil, through a turbine, through a turbine which is connected to the generator, and it goes to the next piston to keep the cycle going. I need to. The Polaris Wave Power Company, which is the one that produces the snake, was founded in 1998 by Richard Yem, Chris Retzler, and David Pisa. The machines they produce range from 750 kilowatt to 1.7 megawatts. This is the prototype. It's in production at the moment. As you can see, compared to the size of the dinghy, it's actually not that big. So this is one of the earlier ones producing the 750 kilowatt. And another video, which won't work. This video just basically shows you how the energy is actually converted. Because of the two axles that the tubes are connected to, the power tube, it doesn't. If it's in one axle, it'll probably snap next time a wave comes and hits it that way. So it's able to rotate with the wave, so go all directions. As you can see, the turbine rotates in the same direction and goes to the generator and back onto the grid, basically. And where we get waves, we also get tides. The first tidal turbine was based in a narrow at Strandford Loch in Northern Ireland. Narrow is where it's a narrow part of the mouth where the sea meets the ocean, and it's where a lot more water is forced through. This is where the energy is. Like pinching the end of a hose pipe. There's a lot more pressure. The turbine itself consists of basically like propellers or wind turbine blades cut through the water. And it's basically just a wing that moves up and down the tower. It was put into production in 2008, and it's still in production now. Weighs 3,000 tonnes and produces no noise emissions as well as zero carbon emissions. And there's a picture of it. So it's a quite large thing. The turbines can change direction depending on the direction of the water flow. So if the water to the sea is coming, if the water is flowing from the sea to the loch, it'll face the sea. If it comes from the loch to the sea, it'll face the loch. So it's a constant flow. It doesn't take long to rotate the blades either. The tips of the blades, when they're vertical, sit 6 meters below the surface of the water, and the whole thing is very tall anyway. So it does take is quite deep. They can withstand, the blades themselves can withstand 40 tonnes of water per hour, and this produces 1.2 megawatts of electricity, which is roughly enough for 1,000 homes. New technology. There are many versions of these products, the Snake and the Tidal, to produce, to work at different areas, different depths globally. This particular type, I think, is based in Australia. And the turbine's in the middle, and it basically gets narrower to the turbine, so there's more pressure going through, and it works both ways. This one, just another, like an underwater wind turbine, basically. The beauty of these two is that you can have like 20 or 30 of them in a farm in a small area, so it produces the electricity. And this type is can be used for a bridge. So we build a bridge across the water, and we also put the turbine underneath. Thank you. Questions?
What source do you think would be best?
The tidal turbine, tidal energy, is more predictable.
Right.
But the technology to actually make them is a lot more, because they make them watertight and strong, the pressure was.
You know, you said that there was one of these ducks in the Penton Firth. Was that actually?
No, it's not. No, we haven't got a duck in Pentonfirth. Well, not as far as I know. What we do have is one similar to this one,
Right.
by a company called Tacardo.
And is that currently supplying power to homes in Caithness?
Not yet. It's still in development phase. 2012 to 2015. But we should be getting 500 kilowatt turbine, or a few of them.
Okay.
That's what the developments are, as far as I know. Just a hunch.
Thought those were my Palamas ones, and not.
Pardon?
I thought those were Palamas one at the end, wasn't it?
I think there is, but I didn't actually find it anywhere on the internet. But I think I have heard that there is a Polaris one.
Is there any environmental impact?
Yes, for these turbine blades, it's what they need to come in to think about is the wildlife that's in the water. Mostly, if it's just fish, like small fish, they can pass through easily. It's the bigger creatures that you need to worry about, as well as the seaweed that gets caught in the rotors or anything for maintenance. But every time every meeting that they have for these, they do consider the environmental issues, and they do have lots of surveys testing in certain areas to monitor the wildlife movement.
How often would that technologies need maintained?
The technologies will need maintaining every few years, 2 or 3 years. But to get, depending on where they are, get them off the seabed and onto the boat or whatever to maintain, it won't actually take that long. And maintenance this itself won't be very much either. But each turbine has a cycle of about 20-25 years.
I was definitely better at my last talk like that. I had good engagement with the audience. Nice technical presentation. Unfortunate that your videos not running smoothly, but they were very interesting to see. You've obviously put a lot of effort in it, and you've done a lot of research.